Alright, bacteria count, our application example to wrap things up. The number n of bacteria in a refrigerated food is given by this function, 20t squared minus 80t plus 500, and the parameters, the domain, would be greater than or equal to 2 and less than or equal to 14, where t is the temperature of the food in degrees Celsius. Alright, so when we remove the food from the refrigeration, the temperature is given by t of t, 4t plus 2, where t is the time in hours. We're going to compose these two functions and interpret its meaning, and then find the time when the bacteria count reaches 2,000. So let's do n of t first. So what we're going to do is n t of t is 4t plus 2. And then the big function here, we're going to have 20. Instead of capital T, we're going to put in 4t plus 2 squared minus 80, 4t plus 2 plus 500. Alright, so we've got some algebra to do here, but we can solve this. This is going to be 20 distributed over 16t squared plus 4 times 2 is 8. We'll double that to get 16t plus 4 minus 80 times 4 is 320t minus, distribute that negative, 160 plus 500. I'm going to distribute this 20 in here. 20 times 16 is 32t squared. Sorry, 320 t squared. 20 times 16 is also 320. In this case it's t plus 80 minus what we already had, 320t minus 160 plus 500. And let's combine our like terms. 320 and 320 are gone, so we have 320 t squared, and we have 580 minus 160, so 480, 420. That would be our solution for the composition. Alright, what this means, let's think about what this means. Little t here is the time in hours. Alright, so this is going to be, big T is the temperature of the food, and the bacteria is the big N. Alright, so if we know how long we've been removing something from refrigeration, we can figure out now directly how much bacteria there is, and we can bypass the temperature function here. Alright, so find the time when the bacteria count reaches 2,000. So we're going to say for B, 2,000 equals our final answer, 320t squared plus 420. Let's go ahead and solve. Subtract 420, we'll get 1580 equals 320t. 1580 over 320. Let's see what we got here. Let's see. If I did 3 times 5, I'd get 1500. So it's got to be a 4 here. 4 times 3 is 1200. And 80. So I'm left with a 300. And so I could go in 0 and 3,000. Interest of time, I'm pulling out my calculator and seeing what we get here. 1580 divided by 320 is 4.93. Take the square root of that and you'll get 2.2-ish, I believe. Yep, 2.22 equals t. And I don't care about the negative answer because we're talking about time here. It's got to be positive. So go ahead and see if you can make heads and tails of 73. Move this out of your way. 73. The number n of bacteria in a refrigerated food is n function. We are then given the t function. Let's do the composition if we can. We're going to have, this is part A. N of, we know that t of t is 3t plus 2. So our composition is going to be 10. 3t plus 2 squared minus 20. 3t plus 2 plus 600. 3t squared is 9t squared. 3 times 2 is 6. We'll double that and get 12t plus 4. We'll get 90t squared plus 120t plus 40. And then we'll bring the rest down here. Minus 60t plus 4, I'm sorry, minus. Distribute that negative. Minus 40 plus 600. Running out of room. Let's clean this up. We've got 90t squared. How many t's do we have? We've got 120 minus 60, so plus 60t. And then how many constants do we have? We got a plus 40 and a minus 40, so we're just left with the plus 600 is our function. All right, let's interpret its meaning in context. We can determine now the amount of bacteria just by knowing how long it's been removed from refrigeration. We no longer need the temperature of the food. We've gotten rid of the big T variable entirely. If we plug in 0.5 as our n, so this was A, let's go ahead and put 0.5 in here. Oh, nope, sorry. They're saying after 0.5 hours, so they're saying T is 0.5. So 0.5 squared and 0.5. We'll plug this in for T, and I'm going to pause this video for a second while I plug it into my calculator. All right, after plugging into the calculator, I got 652.5. So after half an hour, we're going to have 652.5 bacteria, and then find the time when the bacteria count reaches 1,500. So in this case, we're going to say 1,500 equals our whole formula, 90t squared plus 60t plus 600. We can move the 600. Let's see. Let's go ahead and can we factor it? What's the most efficient way? Yeah, let's go ahead and do that. We'll minus the 600 and get 900 equals, I'm going to go ahead and pull a 30t out. 3t nope. I take it back. We're going to have to get 0 on one side and factor it. 0 equals 90t squared plus 60t minus 900. And we'll go ahead and factor this. See if we can do it. Let's see. I know that 30 times 30 is 900. That's not going to work out. Let me pause here for a second and see what we get. Alright, so after taking a look at it, it's not going to factor cleanly, so the best way to solve this is to use our old friend, the quadratic equation, and it looks like we get an answer of about 2.86 if we do that. So if you've gotten this far on this one and want a refresher on the quadratic, be sure to remind me in class, and I will definitely go over the quadratic. That's the x equals plus or minus square root, blah, 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 blah. Okay, if that doesn't sound familiar at all, should. So talk to me about the quadratic in class.